Moment distribution method is applicable for analyzing the intermediate structures like continuous beam and rigid frame. Rigid frame with sway and without sway can be analyzed using this method. This method is based on the iteration procedure. Before the invention of computer, any number of members can be used using this moment distribution method. It is the advantage of moment distribution method. In the moment distribution method, here we see the analysis of continuous beam. This is the two span continuous beam. The span AB length is 6 meter, which carries a UDL 30 kN per meter, and its moment of inertia is 3I. Next, in the span BC, its length is 6 meter, where 72 kN point load it is acting 4 meter from B, and its moment of inertia is 2I. In the analysis of continuous beam, first step is finding the fixed end moment. The next step is the distribution factor. After that, we have to do the distribution cycle. Then we can draw the bending moment diagram. The fixed end moment, it can be calculated for each span using the standard formula for a particular loading cases. So here in the span AB, UDL it is acting. So M of AB, the formula is minus WL square by 12. The answer it is minus 90 kilonewton meter. On the right end, M of BA, it is plus 90 kilonewton meter. Next, in the span BC, point load eccentrically acting. Therefore, formula here is on the left end it is WAB square by L square. The answer is minus 32 kilonewton meter. And in the right end, M of CB, WA square B by L square. Answer is 64 kilonewton meter. Next, we can find the distribution factor. Distribution factor, it is usually found for the intermediate joint. Here B is the intermediate joint, and at the intermediate joint B, we have two members, BA, that is left member, and right member BC. So for BA, for each members, we have to find out the stiffness value. Stiffness value, it is based on the supports. The formula can be used. When far end it is fixed in a particular span, 4EI by L can be used. When far end it is hinged or roller, we can use 3I by L. So when we take BA, B it is the near end and A it is the far end. Therefore, the formula here is 4EI by L. So its corresponding length and moment of inertia it is used and calculated. The value is 2EI. Next, in the span BC, in BC also the far end it is C support, it is a fixed support. The formula is 4EI by L, and substituting the values, we have calculated as 1.33EI. Next, the algebraic sum of these two values it is calculated, so whose value it is 3.33EI. After that, the distribution factor can be calculated using the relation K divided by algebraic K. For member BA it is 0.6 and BC 0.4. So here there is a known fact, the sum of the distribution factor it should come 1, okay, for a particular joint. So here we got 1, therefore our calculation is correct. Next, we can do the distribution cycle. For carrying out the distribution cycle, first we can write the joint. So here joints A, B and C, and member. Under each joint, what are all the members connected, it can be listed. So under A we have AB, B we have the left member BA and right member BC, and C only one member connected, that is CB. The next row we have to write the distribution factor for the intermediate joints, which is calculated in the previous steps, 0.6 and 0.4. Next, we have to write the fixed end moment for each member, what we calculated in the first step, that is minus 90, plus 90, minus 32 and 64. For carrying out the iteration cycle, the intermediate joint, so first it should be taken. So here the intermediate, we have only one intermediate joint, so B and BC. In this case, here the value usually at the intermediate joint, the value on the both end, left and right end, it should be same with a different sign. But here there is a difference, that is 90 and minus 32. So this difference, when we are calculating, we have 90 minus 32, we have 58. This 58, when it will be balanced, so when it becomes minus 58, we can do the it is a balancing. So minus 58, it should be shared at the joint B, which should be shared by the members connecting at the joint B. So minus 58, it should be multiplied with the corresponding distribution factor 0.6. So minus 58 and 0.6, here we have minus 34.8. Next, minus 58 into 0.4, here we have minus 23.2. Okay, now the balancing it is over. Next we have to do the carry over. When one end we are trying to balance, its far end it will be disturbed. So for example, in the member BA, near end it is B and far end it is A. In the near end we are trying to do the balancing. Okay, so therefore the half of the moment it should be carried over to its far end. From BA to AB, half of the value, minus 34.8 divided by 2, minus 17.4. Next value in under B, that is BC, we have minus 23.2. B it is the near end and C is the far end. So here half of the value, it is minus 11.6, that is carried over to CB. Okay, so once this, okay, this is the iteration cycle, doing balancing and carry over, balancing and carry over. So each is the cycle. Okay, it is each cycle comprises of balancing and carry over. This should be continued until the all the intermediate joints values are simultaneously balanced. In this problem, only one joint, and also after carry over, in the carry over step we can see there is no value under B joint. This indicates the cycle it is closed. So once the cycle it is closed, means in each column the value should be summed up with the sign as it is. So from the fixed moment, so the arrow mark it has been shown in the orange color, minus 90 under AB, so minus 90, minus 17.4, both are positive, same values, therefore it is summed up, minus 107.4. Next under BA, 90 minus 34.8, it is 55.2. Next in the BC, minus 32 minus 23.2, so it is added minus 55.2. And CB, 64 minus 11.6, it is 52.6. So here under B, so on the left end we have plus 55.2 and the right end we have minus 55.2. So both are okay, same value with a different sign, therefore the cycle it is closed. So this is the final end moment. Once the final end moment it is calculated, so okay, so we can draw the bending moment diagram. So the final end moment, the clockwise moment. So here there is a diagram showing the end moment's value. So the arrow mark, okay, negative moment it is shown in the anti-clockwise direction, and positive moment, that is plus 55 for BA, it is shown in the clockwise direction. Next we can draw the bending moment diagram. That is first the free bending moment diagram, sagging moment. In this case, each span is considered as a simply supported beam. AB, which carries the UDL, maximum bending moment will occur under the center, whose value magnitude is WL square by 8. Okay. Next in the span BC, point load acting eccentrically, the maximum bending moment will occur under the load. Its value is WAB by L, it is 96 kilonewton meter. Okay, once the free bending moment value is calculated, the final bending moment it can be calculated, final bending moment diagram can be drawn. Okay, so this is the final bending moment diagram. So where the end moments and the free bending moment, that is simply supported bending moment, is incorporated. Thank you.